Okay folks, so we are going to be looking at the area of a variety of other quadrilaterals today, okay, and this week in general. So we've got a few different shapes we're going to be looking at. We're going to be looking at a rhombus, a kite, and what we call an inverted or a V kite. Now, the three formulas for those three shapes are all the same, so that's quite helpful. We're then going to look at parallelogram and a trapezium. Okay, so introducing lots of new shapes. These ones are kind of, I don't want to say less important, but you can always split these into triangles or triangles and rectangles to help you get the area if you forget the formulas. Okay, but obviously if you remember the formulas, they're going to be quicker. Now, for the rhombus and the two kites, the formula is the area is half times what we've got is d times d. Now the d stand for the diagonals. The diagonal of your rhombus is where you've got corner to corner. So if I just sketch that on here, okay, the diagonal of your rhombus is corner to corner that way and corner to corner this way. Okay, let me just scroll it down a little bit so we can actually see the top of the shape. So what we're basically going to need, folks, is to be able to get the area of this is we're going to need this length here, okay, from the top to the bottom of the rhombus, and we're going to need this length here, side to side, and they might be marked inside the rhombus or they might be marked outside the rhombus like I've just done. Okay, so if for instance I tell you that this length here is 14, so the width across the rhombus is 14 and the height here is 24, then they're the lengths of the diagonal of the rhombus. Now, like every other area question we do, we start off by writing down our formula. Now I've already got it written down there, a half times the diagonal times the other diagonal, so the two different letter D's there. So a half times the first diagonal, let's just put in the 24, and then times the second diagonal, which is 14. So our second step, as usual, is to put in the numbers in place of the letters. And then the final step is just to type that into your calculator and get an answer. So our answer is 168, and we're going to need the right units, which is square centimetres. Okay, so you'll be practicing that one, just remembering the formula, putting the numbers in the right place, and getting your answer. Let's do the same for the kite. Okay, so this time we've got, this is our diagonal here from side to side. Let's make this 40 millimeters. And then from top to bottom is our other diagonal. Let's make that 120 millimeters. Okay, so our formula for the area of a kite is the exact same as the area of a rhombus. So we've got a half times diagonal 1 times diagonal 2, or a half d times d. One diagonal is 40 and the other one is 120. Remember, it's not going to matter what way round you put those two numbers. Okay, and then from there, grab your calculator, 40 times 120 and half it, or 0.5 times 40 times 120, and we get 2,400. This one is in millimeters, so we're going to have square millimeters. Okay. Okay, then from there we go on to our inverted kite or our V kite. So this funny little kind of V shape is what we call an inverted or a V-shaped kite. Okay, and that is got the exact same formula as a normal kite. The only thing that's a wee bit different about this is how we get our diagonals. So our diagonal is just across here. Okay, so we've just got across here, that distance there. Okay, and let me make that 15 centimeters. And then the height, the other diagonal, is not the full height of the kite. Okay, so you might wonder, do we go just to the point or do we go all the way down to the bottom? Okay, when we're doing our V-shaped kite, okay, we just go to the point. So it's just this distance here we want, and we'll make that 20 centimeters. Okay, so we don't go all the way down to the bottom. This line I'm putting in blue here, we don't use that part. We just use from point to point. Okay, area is a half of d times d, so we've got a half times 15 times 20, or times 20 times 15, and that's going to give you 150 square centimetres. Okay. And then a parallelogram. The area of a parallelogram is the area of the base times the height. Okay, so this would be your base here. Let's say that this is 1.2 meters. And your height has to be this distance here. Okay, so it's not the slope and length, it's not this length. Okay, it's got to be at right angles, a bit like when we do a triangle, folks. So that is going to be your height there, and let's make that 1.1 meters. Okay, so the area of a parallelogram is just the base, 1.2, times the height, which is 1.1. So we've got our formula, we've put our numbers in, we grab our calculator and we do 1.2 times 1.1, and we get our answer of 1.32, and this one was in meters, so this is square meters. Okay, last shape you're going to look at this week. Okay, so I'm just running through one of each. You've got examples in the textbook to help as well. The last shape you'll do is the trapezium. Now, this one's a wee bit different. What you need to know is that for any general trapezium, the parallel sides are what we call A and B. So this side here is A, and this side here is B, or the other way around. You can do it the other way around. And then the height is obviously the height of the shape from top to bottom. Again, not the sloping sides. The sloping sides have got nothing to do with it. So if I told you that A was 7 centimetres, that B was 12 centimetres, and the height was 9 centimetres, then we're going to put that into our formula. So area is a half of A plus B, so A is 7 and B is 12, times the height, which is 9. Okay, now it's up to you. You know you need to work out the bracket first. Your calculator would do that for you, but if you want to tidy it up non-calculator wise, first of all, this is going to be a half of 19 times 9, because 7 plus 12 is 19. Remember, we would do the brackets first. So we're doing a half, or 0.5, times 19 times 9, and we get 85.5 square centimetres. Okay, so that is your all your different formulas. That's me going through one example of each, and we'll do more in the live classes.